Audio Jungle. Audio Jungle.
Yes, now heading is for this ideal RAMJET, we are going to calculate fuel air ratio, FA, fuel air ratio for ideal RAMJET. Okay, how to do this? We'll take one combustion chamber here, see, combustion chamber. In combustion chamber, what we are going to do? We are going to add fuel here. Okay, so what is the station number? Combustion chamber station number. If you check, combustion chamber station number is nothing but, see here, it is not 2 and not 4, no? Combustion chamber, not 2 and not 4. So I must say here, this is not 2 and this is not 4. Now here in this combustion chamber, from diffuser, the air is what, fresh air is what entering here, like this. This is the fresh air, m dot a. You have added fuel in the combustion chamber. Now, so exit will be gas, and gas is nothing but m dot a plus m dot f. F is the fuel. This is also called m gas. Okay. Now we'll balance the energy here. So total input is equal to total output. This is the energy balancing, total output, total energy balancing. So how to do this? You will write, many times I told you that energy equation. So what you will write, inlet will be m dot a, Cp of air, okay, into station 2 temperature T02 plus what is the input heat, that chemical energy you are adding here. So chemical energy formula is what, m dot f, okay, into heat value. If combustion chamber efficiency they have given to you, you multiply by eta cc, that is the combustion chamber efficiency, is equal to what is the exit, m gas. M gas is nothing but m dot a plus m dot f into Cp of gas into station 4, exit is station 4, so T04. This is the, in turbojet also I had explained this, so no need to explain again. You go and watch previous videos, so you will get that. What is the HV? HV is the heat value. Okay, if you check this, if you multiply divide by m dot a both sides, so what you will get? You will get Cp of air, okay, T02 plus m dot f divided by m dot a. Check here, no? You divide it, eta cc. See, eta cc is the combustion chamber efficiency. Sometimes they have given to you, sometimes they will not give to you, so nothing to worry. M dot a plus m dot f divided by m dot a both side, okay, into Cp of gas into station T04, if I am not wrong. Now you solve it. Okay, if you solve this, then after solving you may get this m dot f CPT02 plus m dot f by m dot a is nothing but eta cc. M dot f by m dot a is nothing but fuel air ratio, which is small f. Also I had explained in turbojet engine, HV. and this is 1 plus small f into Cp of gas into T naught 4. Okay, this is the value. So here it's very easy to you to get the value of small f. What you can do, Cp of air, this is Cp of air, okay, T naught 2, I can take minus this side, so it is Cp of gas T naught 4, I can take f common, so small f, this is Cp of gas T naught 4 minus eta Cc into heat value. Check it if I am not wrong. So what is small f? Small f is nothing but Cp of air T naught 2 minus Cp of gas T naught 4 divided by Cp of gas T naught 4 minus eta Cc into heat. This is the fuel to air ratio. Check the calculation. If any plus minus something is there, you can check it. No? This is the fuel to air ratio, okay, F by A, fuel to air ratio of ideal ramjet. All right, already I have told you if this fuel to air ratio, right, already I have told you if air and gas values are same, Cp of air and Cp of gas, they have not given separately, only one value they have given, you can take as a equal value and rest you can do that. So if Cp of air is equal to Cp of gas, then what you will do? Simply small f is equal to, take this value, so this is nothing but any value you can write Cp T naught 2 minus Cp T naught 4 divided by Cp T naught 4 minus eta Cc into heat value, right? So this is the fuel to air ratio. Now the last is, we are going to calculate fuel to thrust value for the thrust value for the ideal ramjet. How to get that? Very simple, like others engine, we can write the thrust equation for this ramjet. This is exit, okay, you can say this is the combustion chamber. Here fuel is what added, m dot f, and this is the Okay, now all right, spike. Now you can say this is the air inlet m dot a here, and the inlet velocity is nothing but v infinity. So what will be the thrust? Because we are assuming that fully expansion case, so PE is equal to PA, so there is no pressure thrust. I will write the equation, you can understand simply. What is the equation we have? We have here m dot a plus m dot f into exit velocity minus m dot a into inlet velocity plus PE minus PA into A exit. But this pressure thrust, because it is fully expansion, so this value will be 0. What thrust you will have? Simple. You will have T is equal to, take the common m dot a, what you will get? 1 plus m dot f by m dot a into VE minus m dot a into V infinity. If you solve this, what you will get? Thrust is equal to m dot a. What is the 1 plus mf by ma? Mf by ma is nothing but mass of fuel divided by mass of air. Let me write once. So this you can write m dot a 1 plus m dot f by m dot a is small f, fuel air ratio, VE minus V infinity. This is what thrust. Sometimes fuel is what very less, m dot f is very less than m dot f, so fuel air ratio you can take 0. So what will be thrust that time? It will be m dot a in bracket VE minus V infinity. Okay. If they do not have given fuel air ratio, you can take this one. If they are saying calculate specific thrust, so what will be specific thrust? Fs thrust divided by m dot a. It is nothing but VE minus V infinity. Right? The specific thrust, if you check, directly proportional to the velocity difference. Done? All right, ideal RAMJET. So what is ideal RAMJET? What is the conditions? What are the outcome when we have gone through the ideal RAMJET, then we had seen the outcome. Basically for the ideal ramjet, like most importantly it was inlet Mach number is equal to outlet Mach number. We had proved this, but the condition was if inlet and exit fluid conditions are same, okay, like gamma value and R value. So that we had seen. You can go and watch that previous videos lecture. So now onward we will solve few numericals based on this ideal ramjet, and this is gate 2020. Similarly, just like 2020, many years they have asked question, okay. So few questions will solve here. The question is the design flight Mach number design flight Mach number of ideal ramjet ramjet engine is 2.8. This is the Mach number, okay. Full stop. The stagnation temperature of air at the exit of the combustor is combustor is 2400 Kelvin. 2400 Kelvin, right? Assuming the specific heat ratio specific heat ratio of 1.4 and gas constant of 287 joule per kg Kelvin, full stop. The velocity of air at the exit of the engine is it's a fill in the blank in meter per second, okay. Round up to 1 decimal place, and this question is for 2 marks. See the solution of this problem, okay. Now see what value they have given to us. 2.8 they have given the design flight Mach number. Design flight Mach number means m infinity they have given to us. How much? It is 2.8, or you can say this is the aircraft Mach number, ma also you can say, okay. Aircraft Mach number or flight Mach number or m infinity, okay. Free stream Mach number, meaning is same. 2.8 they have given to us. Stagnation temperature of air at the exit of combustor is 2400 Kelvin. So exit exit of combustor. So temperature, it's a stagnation temperature. Okay, it's a stagnation temperature at exit of combustor. They have given how much? 2400 Kelvin. They are assuming the specific heat ratio of 1.4 and gas constant is this. Okay, this value they have given to us. So specific heat ratio means they have given gamma. Okay, gamma is the specific heat ratio 1.4, and R for this gas they have given to us how much? 287 joule per kg Kelvin. This is the value. So what we'll do? So we'll go to the next page. See, this type of problem definitely they will ask to you, and be very specific while you are calculating. If problem is what simple, your calculation should be perfect. Otherwise, in hurry, if you go and solve, even the problem is simple, but mistake is there, then there is the difficulties. Okay. So fill in the blank. There is no negative mark, directly you will lose 2 marks. Okay. There is no negative mark for fill in the blank. So if you go for the RAMJET, ideal RAMJET, so that numbering I had given, if you remember, this is the ideal RAMJET. Okay, and if you go for the numbering, so here this is what A. Somewhere if you draw the spike here, okay, this was 1, and here it is 2. Okay, then I had taken 3 here. This was 4, this was 5, and this was the exit, it was 6. Okay, and here the flow was fully expanded going like this. All right, here a combustor, this is what combustor, here, and this was one time I need to draw, next time I will use this diagram everywhere. Nozzle, and here this is what diffuser. All right, in the problem what they have said, the exit of combustor they have given to us. Exit of combustor is nothing but what is the exit of combustor? 4, and the stagnation temperature of exit of combustor they have given 204, and it is nothing but 2400 Kelvin. MA they have given to us how much? 2.8. These are the values. This is the M exit and this is the M A. Whatever the flow is going on, for that M infinity Mach number is given, and this is the Mach number of the ramjet engine. All right. So for ideal ramjet, now recall last lecture. For ideal ramjet, what was the conclusion? If you remember, we had proved it was inlet Mach number is equal to exit Mach number. Yes or no? We had proved this. Inlet Mach number is equal to exit number. This was proved. They have given T04 2400 Kelvin. This is the temperature they have given to us. Now we'll use this also for the further calculation. Now they are asking what is the velocity at the exit. They are asking what is the velocity at exit. I must say this velocity is nothing but V exit. All right, we can say this velocity is nothing but v exit. All right, exit velocity, right? Ve is equal to, this is the second point, v infinity, it was T naught 6 divided by T naught A. What was T naught 6? This we have proved already. T naught 6 is the total temperature at the exit, and T naught A is the total temperature at the inlet. We had proved this, okay? We had proved this, or the same thing we had said, okay, that velocity we can take in terms of static temperature also. This value was TE divided by TE. This also we had said, okay? So total temperature at the exit, see here, total temperature at the exit, I told you in nozzle we are not adding any heat, so whatever the T04, this T04 is equal to T05 is equal to T06. When I had explained RAMJET engine, that time when I had explained RAMJET, that time I had given this relation, because in nozzle we are not adding any heat, so T04 is equal to T06 total temperature. What is the T naught A? Okay, T naught A we can calculate T naught A, because the Mach number they have given to us. Okay, if the Mach number they have given to us, then definitely we can get that value. Now the relation we can write here. What is the relation we have? MA is equal to ME. Okay, in this relation, what is this ME? If you check, ME is nothing but VE, exit velocity, because we have to find exit velocity, gamma R TE, exit static temperature. Yes or no? ME is the exit Mach number, and we have to find that velocity at the exit. Hence, I have written VE divided by root of gamma RT. This formula I can write easily. Okay, and this is equal to M A, which is given how much? 2.8. Yes or no? Now, if you check what we have written, ME is equal to VE root of gamma RTE, and this is equal to MA. This is the ideal RAMJET, hence MA is equal to ME, and MA they have given to us 2.8. Now, so gamma and R value they have given to us. What is VE? VE is nothing but 2.8 root gamma R TE. TE, remember, this is static temperature. We do not have a static temperature. What we have? We have total temperature, T04. T04 is nothing but T06, and what is T06? This is nothing but T0E, exit total temperature. Yes, when I have explained this ideal RAMJET, that time everything I had explained. So we cannot say something is what unknown or something is what new. Everything is what known here, because each and every points I had explained in my last lecture. So T06 is T0E. All right. Now, what is the relation? Isentropic relation, because ideal RAMJET means isentropic relation you can apply. So, what is the isentropic relation for the exit? It is nothing but T naught E by TE is equal to 1 plus gamma minus 1 by 2 ME square. All right. What is the TE? TE is nothing but T naught E divided by 1 plus gamma minus 1 by 2 ME. What is ME? ME is nothing but MA, and what is MA? It is 2.8. So you can write here MA square. Okay. What will be the TE value? If you go and calculate this TE value, so it is T naught E, which is nothing but 2400 Kelvin, divided by 1 plus gamma they have given 1.4 minus 1 divided by 2, gamma minus 1 by 2 into MA. MA is nothing but ME, which is nothing but 2.8. 2.8 square. If you do this, then you will get TE value. Okay, do it. Here this value is nothing but 934.57 Kelvin. This is the temperature. So this is the TE. In the problem they had asked for calculation of exit velocity, hence what you will do, write the formula. I have given the formula, use that formula. What is VE? VE is nothing but, check here, it is 2.8 root of gamma RT. 2.8 gamma 1.4 R. In the problem 287 it is given, into TE you have calculated 934.57, you can write 935 approximate, because this is the approximate value I have written. So now do this, calculate it. So this is what exit velocity, right? Simple formula, within 2 minutes you can solve. Okay, if you go fast, in single attempt only you can finish this numerical. It's very simple, but it is for 2 marks. So this value is nothing but 1715.8 meter per second. See, this is the speed, exit speed, okay, exit velocity you can say, of ideal ramjet. So this is your answer. Okay, 2 marks. So check, in this problem it was given for 2 marks, it was fill in the blank. 15.8 meter per second. There is no negative mark for the fill in the blank problem, but you have to be very careful, because they will give the reason in the computer will take reason, like reason in the sense approximate value, suppose 17.13 to 17.17, like that they have given the range. In that range or region you can say that value should be there. If it is beyond that region, beyond that range, then it will not be considered as a correct answer. Hope you understood. Now, so this is problem number 2. Ideal ramjet. Ideal ramjet. Okay. Now the question is, a cruise missile, with an ideal ramjet engine is flying, ramjet is flying at Mach 4.0 at an altitude where the ambient temperature is where the ambient temperature is 100 Kelvin. Consider the ratio of specific heat gamma 1.4 and specific gas constant which is nothing but R 287 joule per kg Kelvin. If the stagnation temperature in the combustion chamber is equal to 2310 Kelvin, the speed of exhaust gases, it is also in meter per second, is again fill in the blank. Now this problem they had asked in GATE 2014. Check. That's the reason I always used to tell to the students, please solve previous year question. They have said condition of ideal ramjet engine flying at Mach number 4.0 they have given to us, and ambient temperature condition they have given 100 Kelvin, gamma value they have given to us, R value they have given to us, stagnation temperature in the combustion chamber is equal to this temperature they have given to us, speed of exhaust gases, this question and this question. What is the difference? The velocity at the exit they have asked. Rest similar question like Mach number given here 2.8, there was 4.0. Combustor exit temperature 2400 Kelvin, here they have given I think 2310 Kelvin. Rest gamma 1.4, R2, everything same. So for that reason I always used to, and see this question paper was 2020, GATE 2020, and this was GATE 2014 I think. So see GATE 2014 now. So that's the reason I always used to tell, please keep solving previous year problems. Okay, if you are solving previous year problems, so definitely you will get benefit of it. Similar kind of problems, I mean exactly never they will repeat the question, but at least you should get idea, okay, this type of question need to prepare because questions they are asking like that, like this only. Yes or no? Now here we have to process this problem in same way like previous. So what to do? Simple, we have condition. What is the condition we have? MA is equal to ME. All right, and we all know the Mach number at the exit is nothing but VE, exit velocity divided by root of gamma R TE. All right, this MA flying at Mach number of 4.0, so MA is given 4.0. We need to calculate VE. What is the exit velocity VE now? VE is nothing but 4.0 root of gamma R TE. This is what we exhaust velocity or exit velocity. What is TE? That formula I already have written for the previous problem. Similarly, I am writing here. This is the isentropic relation at the exit 1 plus gamma minus 1 by 2. This is what ME square. What is TE? You can write T naught E divided by 1 plus gamma minus 1 by 2. ME is nothing but MA square. We can have this T naught E. How much I think? It's a 2310. 2310. Gamma they have given same 1.4 minus 1 by 2. Mach number they have given 4 square. You will calculate TE. Right? So process are same like previous problem. That's the reason back to back I have solved this problem, so you can realize they are asking similar kind of problems, so you need to practice question paper as much as possible. All right, done. So TE we have to find here. This value you have calculated pi 50 Kelvin. This is what TE. So again I told you this type of problem hardly it will take 2 minutes only. If you continuous calculate value and keep putting value in further exit velocity formula, then hardly it will take 2 minutes. So now we'll go for the exit velocity. It is nothing but gamma r TE into 4.0. Now if you do that, how much you will get? See, 4.0 in root it is nothing but 4.0 will be there, right? Okay. Yes. Now so gamma is 1.4, 287 R value, TE is 550. This is the value. Now if you calculate VE, check. So approximate value you will get 1880 meter per second. This is what exit velocity. Yes or no? This is also for, this problem is also for 2 marks. So ideal RAMJET, hope you understood what type of problem they are asking. It's a very simple problem they are asking. Only concept you should know. What is the concept? This I told you, this is the one very important conclusion in my previous lecture when I had gone through the full RAMJET, ideal RAMJET explanation. That time I had proved this, how you will have MA is equal to ME, and I had given the relation between exit velocity and inlet velocity with respect to temperature. That also you had seen, yes or no? So no doubt whatever you had attended last lecture for ideal RAMJET, based on that we are solving problems. So hope you all are getting that. Okay, it's very simple only, very simple. So this is done, right? So what is the answer? Answer is 1880 meter per second. Here it is given itself, so you have to write this number only, that's all. This number you have to write 1880. From virtual calculator you have to write this number 1880 meter per second. This problem was asked in GATE 2014. Now we'll go for the next question, and this is GATE 2010. Okay, in the GATE 2010 also they had asked question based on this ideal RAMJET, and this is nothing but problem 3. It is GATE 2010. It is also for 2 marks. So a question is, a missile with a ramjet engine is flying in the air. The temperature at the inlet, the temperature at the inlet and outlet of the combustor are 1200 Kelvin and 2500 Kelvin. Okay, respectively. respectively. The heating value of the fuel is 43 megajoule per kg Kelvin. Sorry, per kg only, not Kelvin, because it's a heat value, not a specific heat. No? Okay. Per kg, and the burner. What is the burner? Burner is combustion chamber, okay, or combustor. And the burner efficiency is 90%, considering full stop, considering the working fluid, to be air, okay. They have given here CP 1005 joule per kg Kelvin and gamma 1.4, okay. The fuel air ratio small f. Fuel air ratio means m dot f by m dot a, okay. For the engine is equal to, option they have given to us A, B, C and D. What is A? A they have given 0.032. B they have given 0.036. C they have given 0.042 and D they have given 0.026. See, very close answer they have given to us. No? Now, so for ideal RAMJET, everything like check in this problem. All the value they have given, like the inlet and outlet of the combustor value they have given to us, okay. So here ideal RAMJET condition, like MA and ME will be same. It is not like that. Why? Because we are going for the calculation in combustion chamber, and in fact here that burner efficiency, burner means combustion chamber, that efficiency is given. So obviously it is not ideal case, it is actual RAMJET engine, okay. But nothing to worry, okay. Once question will be asking from ideal RAMJET, so they want to relate MA is equal to ME, and based on that they will ask question, just like previous two questions continuously you had seen, okay. But in this case we need to calculate fuel air ratio and also this is the actual condition, and hence burner efficiency also given, okay. So we'll calculate, it's very basic only. What you will do, you will just make here the combustion chamber. This is what combustion chamber here, and simply we have to balance the energy, that's all in this case, okay. This is what combustion chamber or burner or combustor you can say. Check the numbering. In previous problem you had drawn RAMJET engine, so numbering you can check here. What is the numbering? See numbering here. This numbering is inlet of the combustion chamber is nothing but 0.2 and exit of combustion chamber is nothing but 0.4. So that stagnation value will write here, okay, because in this problem they had mentioned or not the temperature at the inlet and exit. They had not said it is stagnation or what. If they have not given stagnation, Also you need to consider stagnation value. Why? Because it is in combustion chamber, and in combustion chamber we have to talk in stagnation. Means inside the engine, inlet and exit can be static, but inside the engine at any station it will be stagnation only if it is given. Okay, so directly you can say this is nothing but station 2 and this is station 4. So T02, they have given to us how much? It is given 1200 Kelvin. It is 1200 Kelvin, and T04 they have given to us how much it is? I think 2500 Kelvin. All right, 2500 Kelvin. Done. Now here, if you see, this is the inlet of combustor basically. So here mass of air alone is coming, and here, because fuel is what adding here, so this fuel is nothing but m dot f. Okay, done. And this combined will go at the exit. So this combined is nothing but m dot a plus m dot f, which is nothing but m gas, you can see now. Yes. So if you write the energy balancing, so total inlet is equal to outlet. I had given that energy equation. So what is the total energy added here at the inlet? So total energy added to the combustion chamber is equal to total energy at the exit. So basically this is what energy balancing. Okay, exit, no? Not exist, exit. So energy balancing. So how to write this? It's very simple. What you will do at the inlet in terms of this m dot a, what you can write? M dot a, okay, into Cp, mass flow rate, into Cp into T naught. So this is the thermal energy which is coming from the diffuser, and it is directly supplied to the combustion chamber. So this is the thermal energy coming from the diffuser. Now this chemical energy in terms of, you can say, mass of the fuel flow is what adding in combustion chamber. So this is the chemical energy, and burner efficiency also they have given. So eta Cc you can say, or eta B, eta B or eta C. See the burner efficiency they have given to us. Burner efficiency means combustion chamber efficiency. So if they have given, you consider, otherwise you can take one also. But you always remember eta Cc will be, in practice you always remember this eta Cc here always. When the heat is what added, then eta Cc into m dot f into heat value, or sometimes it is called calorific value. So this is the equivalent chemical energy which is adding in combustion chamber. And what is the exit? Exit is nothing but mass flow rate at exit is m dot a plus m dot f into Cp. Okay, obviously this is Cp of gas and this is Cp of air. There should not be any confusion. And at this end, what is the temperature? T04, right? As I told you that when I explained this component in jet engine, I explained that day right here. So this is what fuel injector. Point 3 is just a flame holder, you can say, okay, because very high speed it is going, so flame may blow out. So you are using flame holder, you can say, at station 3, but combustor started at point 2 and ended at point 4. So there should not be any confusion, okay. Anyway, now what I was saying, check this. This is the energy balance, okay. So I told you Cp of air and Cp of gas. In the problem, if they have given separately, then you use Cp of air or Cp of gas. See, considering the working fluid, they have said considering the working fluid to be air. They said air. They are not considering gas. So Cp will be common for both, because only one Cp they have given. They had said working fluid to be air, and Cp is given this. If they have not given 2 Cp, some in few problems they will give, they will say like Cp of air is this and Cp of gas is this. That time separately you take. But when they have not given Cp of air and Cp of gas separately, so whatever the Cp it is given, it will be common for both. Hope you understood this. So now I will write this equation once again. So it is nothing but m dot, now Cp is common, T naught 2 plus burner efficiency or combustion chamber efficiency into m dot F into heat value is equal to m dot A plus m dot F, and Cp of gas they have not given, so I am writing only Cp so you can understand that, and it is nothing but T naught 4. Divide by m dot A both sides, so what you will get, Cp T naught 2 plus eta Cc m dot F divided by m dot A, heat value is equal to m dot A by m dot A plus m dot F by m dot A into Cp of gas T naught 4. What is the m dot F to take common? So you may have okay, one more line I think I should write, Cp T naught 2 and minus this should be, okay, one more line I need to write, eta Cc m dot F by m dot A is nothing but fuel ratio small f into Hv, m dot A by m dot A 1 plus m dot F by m dot A small f which is fuel air ratio into Cp T naught 4. I need to calculate this small f, so what I will do, I will take small f common here, so this is nothing but eta Cc heat value, take this side, so it is Cp T naught 4 is equal to Cp T naught 4 minus this value, you can take this side, Cp T naught 2. What is a small f? You can write here Cp common, so it is 1004, it is given to us. What is T naught 4? See that value, I think 2500. So you write this value 2500 minus T naught 2 is 1200 and divided by this is eta Cc. What is the burner efficiency they have given to us? 90% and heat value is 43 megajoule. So 90% means eta Cc is 0.9, 43 megajoule, 43 into megajoule means 10 to the power 6 heat value minus Cp which is nothing but 1005 which is common for all. T naught 4 is 2500. We'll calculate this. After calculating this, we'll have a value here. It is what we are getting, 0.0361. This is the value, right? Check the option, which one is correct? 0.036. So option D is correct. This one. So what is the correct answer? Correct option is B. Okay, 0.0361 or 0.0361. All right. Now, as I told you, this type of question they are asking very frequently, and it is for 2 marks. Okay, always remember. So don't commit any kind of mistake. Nice. We'll go for next then. Problem. This is problem 4, and we have ideal RAMJET now. And this is GATE 2009 for 2 marks. This is also for 2 marks. Okay. Now see. And ideal RAMJET is flying at an altitude of 10 kilometer with a velocity of 1 kilometer per second. the ambient pressure is 0.25 bar and temperature is 225 Kelvin. The exhaust gases from the engine are optimally expanded and leave the nozzle at 900 Kelvin if the specific heat ratio means gamma remains constant. The specific thrust developed by the engine is approximately. What is that specific thrust? Option A, 1000 Newton second per kg. Option B, 2000 Newton second per kg. Option C, 500 Newton second per kg. Option D, 4000 Newton second per kg. We'll go for the solution of this problem, and it's very simple. As I told you, each problem, if you check on an average, hardly it will take 2 to 3 minutes of ideal RAMJET. So see, it is flying at some altitude 10 kilometer, but at that temperature, that value directly they have given to us, so no need to calculate anything. If it is required, if it is not required, it's okay. Exhaust gases from the engine are optimally expanded. I told you many times, fully expansion, optimal expansion means exit pressure is equal to ambient pressure. That's the mean of it. And have the nozzle at 900 Kelvin. So they have said, they see the exhaust gases from the engine are optimally expanded and leave the nozzle at, so this is the exit value it is given, so it is the static value, no? If the specific heat ratio gamma remains constant, means gamma for air and gamma for gas. I told you that time when I have concluded ideally RAMJET, and that time I had given one value. What I said for ideal RAMJET, listen carefully, okay? Ideal RAMJET, I had said MA is equal to ME. So this condition was very special. When gamma of air is equal to gamma of gas. When R of air is equal to R of gas. When I proved this, I told you when fluids are not changing their property, okay, means because at inlet it is air, but once it is going to exit, definitely it will be gas, because mass flow rate of fuel is also added in combustion chamber, so definitely it becomes gas. So gamma and R value will change, but here it is clearly mentioned it is constant, okay. So if gamma air and gamma gas both are same, R, which is the gas constant, characteristic gas constant, R air and R gas is not constant, then MA is equal to ME. This is the proved in last lecture. I had proved this, okay. Now we'll go for the calculation. So fully expansion or optimally expanded. What do you mean by optimally expanded? It means PE. Let me correct this. It is PE. Okay. So PE is equal to PA. That will indicate fully expansion, fully, or it is also called optimal expansion. Okay. And third point, what we had seen for the ideal RAMJET, it was VE exit. What was the VE exit? It was V infinity. Okay. In bracket, it was exit temperature, which was T06 divided by T0 A. And that also, because Mach number MA and ME were same, so this also you can write VE is equal to V infinity T exit by T. In static form also you can write. Okay, this was the formula. So now static exit temperature of the nozzle they have given to us. So check this 900 Kelvin, this is the exit temperature. Okay, they have given to us. TA 225, this they have given to us. Velocity at the inlet they have not given. They have given here. See 1 kilometer here. This velocity also they have given to us. So now your problem is what solve. What you will do? See, this V exit is equal to V infinity in bracket PE by PA. To solve all the value you have to keep here. So what you will get? Check. V infinity they have given 1 kilometer per second, means 1000 meter per second. TE exit temperature, I think 900 Kelvin they have given to us, and ambient temperature 225. So this is what 900 Kelvin and this is 225. Need to calculate this VE. So this value is nothing but 2000 meter per second. Why we have calculated this? Because if you read this problem, they had asked specific thrust. How to get the specific thrust? For that you should know, if they are asking thrust, you should know exit velocity. For that reason we have calculated. Now for the engine, suppose this is what engine, okay, this is what exit, this is exit. Okay, so we have V exit, we have PE, but it is equal to ambient pressure. Why? Because fully expanded they have given to us, and definitely here the flow is not coming with velocity VA or V infinity. Okay, now for this, you know, this is nothing but RAMJET. Something like this. Okay, if I write thrust equation, so what will be the thrust equation? Check, fuel air ratio is given for this problem. If they have not given fuel air ratio, then you can neglect. Fuel air ratio they have not given. Okay, mass flow rate or fuel air ratio they have not given. Then what you will say? Full thrust equation I will write here. You need to relate. So MA, this is the actual equation. MA plus M dot F into VE minus M dot A into V infinity, okay, plus PE minus PA, okay, into exit. So this part will be 0. This part will be 0. Why? Because they have said optimally expanded. Yes or no? Now what we have? So T is equal to what we have here, M dot A plus m dot f VE minus m dot a V infinity. What we can write, thrust is equal to m dot a plus m dot f to VE m dot a into V infinity. You can write m dot a in bracket 1 plus m dot a by m dot a VE minus V infinity. Okay. So this is nothing but 1 plus m dot a by m dot a is nothing but fuel air ratio. You have to check fuel air ratio they have given to us or not. If they have not given, check in the problem fuel air ratio they have not given to us. Okay. Here not mass flow rate of fuel or not mass fuel air ratio they have given, so you can neglect. I told you that time also. So this part you can neglect. This is also 0. So what you will have m dot a in bracket, you have VE minus V infinity, and this is what thrust. What is the specific thrust now? What is the specific thrust now? Specific thrust is nothing but Fs, thrust divided by mass flow rate of air, which is nothing but VE minus V infinity. Yes. So Fs is thrust divided by mass flow rate of air. This formula directly I had given when I had explained RAMJET. So VE minus V infinity. Okay. Now, if you check the data what they have given to us, so VE just now we have calculated how much it is, 2000, and V infinity they had given 1000, right? So it is nothing but Fs. VE you have calculated 2000. V infinity, that aircraft speed they had given 1 kilometer per second, means 1000 meter per second. If you calculate Fs, it is 1000 meter per second, or the unit of the specific thrust is also 1000, okay, Newton second per kg. Actually how it comes, you can check. Thrust is nothing but Newton divided by mass flow rate of air. What is the mass flow rate of air? Kg per second. So you can write Newton second by kg. So ultimately what is your answer? Answer is specific thrust is nothing but 1000 Newtons per second per kg. This is the value. This is your answer. Check the option 1000 Newton second per kg, first option. So what is the correct answer? Correct option is A. Done.